Welcome to the third lecture in Module 4. And in the last lecture, we talked about how to create classes. And now, in this lecture, we'll talk about how you manipulate the objects and variables that you create from those classes. As I've already mentioned, everything in Ruby is an object. So everything inherits from this parent superclass called object. And all of the methods that are in that class are available to all of the objects that you create in Ruby, unless you override them. And you can override, as I've already showed you, you can always open up a class and override its methods. So if you want to experiment with this, again, open up IRB and just type 1.class, and it'll tell you that 1 is of type fixnum. So it's telling you that it's from the fixnum class. You can leave off of the parentheses. I already showed you this. So leave off the parentheses, you get the same result. If I say 1.0 and then type class, it knows, Ruby knows that I'm talking about a floating point value now. So it returns type floating point, or class floating point in this case. And if I enclose something in quotes, either single or double, query the type of class that I have, it'll tell me it's a string. The syntax in Ruby is sensitive to capitalization, and there's some rules about how you should capitalize things in Ruby as well that you should use by convention, because most people who use the Ruby programming language follow those conventions in order to avoid confusion. So in most cases, capitalized variables are treated as constants. And we've already talked about the fact that Ruby you won't see things like fixnum and then the name of the variable. There are no variable declarations. If you need a variable, you just use it. You start using it, and it's automatically created. So if you assign a value to some literal, then a variable of the appropriate type is created, and it's named after that literal. So here's an example. Again, open up IRB, type a equal 2. There's a variable a that's created that has the value 2. That's what the return value shows you there. And so if you type a, you can prove to yourself that that variable now exists. It's of type fixnum. You can prove that by typing a.class. There's also a bignum class, by the way, if you need larger integers. So you can also create variables of type bignum. If I put quotes around the 2, that's no longer an integer. It's a string. So if you type a, it's going to return that string. And you can again inspect it by typing a.class. Now, something that's a little different than other programming languages is that all assignments in Ruby are done by reference. If you use C or C++, by default, assignments are done by value. So you have to be careful and be aware of that in Ruby. So a variable just holds a reference to an object, doesn't really care the type of the object, and again, because it knows that everything ultimately inherits from the root object called capital object. Ruby has something called parallel assignment that's kind of interesting. So here I've opened up IRB, type a equal 2, b equal 1, creates those variables. If I say puts ab, it'll print out both of those. And now if I say a comma b equal b comma a, that's doing a parallel assignment which acts to swap those two values. Quite interesting, you can do that all on one line. The naming conventions in Ruby that I have just referred to and that you should follow are as follows. So very simple naming convention where you denote the scope of the variable and also the type of the variable by how you name it. So if you just use name, then that's probably a local variable. So name itself is the literal here. If I put this @ sign in front of it, then that's indicating that name is an instance variable. If I put 2 @ signs in front of it, then I'm indicating that that variable is a class variable. In other words, a class variable, again, there's only one such variable defined for the entire class, where with an instance variable, a copy of that instance variable is created for every object of a particular class. If you use the $, that indicates that what you're working with is a global variable, and typically you capitalize that variable name as well. So this @ and $, these are called sigils, and they're intended to enhance readability so that as you're looking through code, and in fact open up a controller inside Rails and take a look at it, you'll see that @ symbol used quite extensively throughout your controller. That's used just to make it easier for you to identify the type of the variable that you're working with. Now, the convention is that lowercase letters are used for local variables, and to use underscores as well. rather than camel case. I showed you camel case where you use uppercase for the beginning of each word and you take out all the spaces. For multi-word names, in camel case, you take out the spaces. And the other convention, again, for local variables is to use an underscore instead. Now, constants are any name that starts with an uppercase letter, and the case is the convention is to use underscores for constants. Now, the classes and modules, they're treated as constants, so that's why you always see those appear using uppercase. The convention, again, is to use camel case for the case of the classes and modules. For constants, it's uppercase, but you use the underscore. So that's kind of how people use Ruby to tell things apart. Now, one of the last things I wanted to mention is this notion that if you create a variable, just the appropriate type of variable is created. I showed you that when I said a equal 2, and then I said a equal 2 with quotes around it. It created in one case an integer, and the next case a string. This is something called duck typing. And the reason it's called duck typing is because the type of the variable is determined by what it currently looks like. In other words, if it looks like a duck and it walks and talks like a duck, it's a duck. That's where that name comes from. So this notion of the type of a variable is determined by what you assign to it, that's called duck typing. This completes the third lecture in Module 4.